Let's solve some quadratic equations using the quadratic formula. Now, the quadratic formula is just that, it's a formula. What we do is we take values from the equation and we plug them into a formula and calculate using order of operations to come up with the solutions. Now, we have to identify those values correctly. To do that, we need 0 on one side of the equation. The values we're going to need will be the coefficient of the x squared term, which we call a, the coefficient of the x term, which we call b, and then the constant term, which we call c. Let's look at an example, x squared minus 5x minus 6 equals 0. I want to show the solutions of this two ways. First, using factoring, which we did a lot earlier this term. If I factor the left-hand side, remember this is equal to 0, so I'm going to be able to use the zero product principle. I'm going to get x minus 6 times x plus 1. Setting each of these factors equal to 0 with the zero product principle, x minus 6 equals 0 gives me x equals 6 as a solution, and x plus 1 equals 0 gives me x equals negative 1 as a solution. So those are the solutions we know from the previous technique we had. As a review, using the quadratic formula, we need to pick out a, b, and c. Now, a is going to be the coefficient of the x squared term. If we don't see anything multiplying the x squared term, it's implied to be 1. Because 1 times anything is that thing. B is going to be the constant in front of, or multiplying, the x term, so negative 5. And C is the constant all by itself, negative 6. So those are our values. We're going to plug them into the quadratic formula. X is equal to, we're going to use negative b, so that's negative 5, plus or minus the square root of negative 5 squared. Now we need to square all of that, including the negative. So whenever you square a b value, whether it's positive or negative, you will get a positive value. Negative 4 or minus 4 times a is 1 and then c is negative 6. Now that's all over 2 times a. Now let me just make one note about notation. Make sure that your square root bar goes all the way over what's underneath there in the formula, and your fraction bar goes entirely underneath the numerator. Now let's simplify. X is equal to, well, negative is a positive 5, plus or minus. When we do the calculations underneath the square root, make sure you square and multiply first. 4 times 1 times 6 is 24, and then minus a negative would be positive 24. So we're going to actually add 25 and 24 instead of subtracting. All over 2 times 1 is 2. Continuing, we get x is equal to 5 plus or minus, add the inside, that would be 49, all over 2. And then the square root of 49 is going to be 7. So I have 5 plus or minus 7 all over 2. Now, to do the plus minus, we need to split up the statement. We're going to have 5 plus 7 over 2, and we're going to have 5 minus 7 over 2. It's important that you separate them at this stage because they will result in different calculations. 5 plus 7 is 12, divided by 2 is 6. 5 minus 7 is negative 2, divided by 2 is negative 1. Notice, same answers that I got when I factored. Now let's compare the work. Factoring took me literally 3 steps. I set each factor at 0, and I got my solutions. The quadratic formula took me multiple steps. 1, 2, 3, 4, 5, 6 potentially steps. So it does take longer. So generally what I say is if your polynomial that is set equal to 0 is factorable, factoring is easier. But not all polynomials factor. As we've seen, some polynomials are prime. If that's the case, then the quadratic formula will get you to the answer every time. So the quadratic formula is very valuable. The other useful thing about the quadratic formula is sometimes we've all seen situations where we struggle to find the correct factorization. When we can't factor or we can't quite see how to factor, the quadratic formula will also get you there to the answer. It may be a little longer, but it's consistent and it gets you there. All right, let's look at another example. What we have here is 4x squared plus 2 equals negative 7x. Now we don't have 0 on one side, so to find a, b, and c, it is ideal to get 0 on one side. So let's move that 7x over. And when I move it over, it's going to become positive 7x. And make sure that you write these terms in descending order. You see how I put the 7x in the middle between x squared and the constant? That way it's in the same format as the original definition of a, b, and c. So a is the coefficient of the x squared term, b is the coefficient of the x term, So a is 4, b is 7, and then c is the constant term of 2. Plugging those into the formula, x is equal to negative b, so negative 7, plus or minus the square root of b squared, so 7 squared, minus 4 times a is 4 and c is 2. Now that's all over 2 times 4, which is a. Simplifying at this point, negative 7 plus or minus the square root of, do the square and the multiplication separately, so 49 minus 4 times 4 is 16 times 2 is 32, all over 8. Continue our simplification. We get x is equal to negative 7 plus or minus the square root of 17 over 8. Now the square root of 17 will not simplify like the square root of 49 did up here. So our answers, if we don't want to throw anything into the computer, would just be this fraction split up so you can see the plus and minus separately. So negative 7 plus the square root of 17 over 8 would be one solution, and negative 7 minus the square root of 17 over 8 would be the second solution. Because we haven't rounded, we would often call these the exact solutions. Now if we do round, which we could do, especially in an application, we would get in the calculator negative 0.36 for the first fraction here, and negative 1.39 for the second fraction. Go ahead and try that and make sure you are seeing the calculations correctly. One thing to be aware of is when you do this kind of calculation in the calculator, you do need to make sure that you calculate the numerators before you divide by that 8. You need to entirely calculate that. Using parentheses is a good idea. Now, checking, we can either check with the exact values, which means we need to do quite a bit of calculation by hand with square roots, plugging them back in, or a quick way to do it is to use these approximate values. I'll give you an example of that. So if I put negative 1.39 into the original equation, I would have 4 times negative 1.39 squared plus 2, and on the other side I'd have negative 7 times negative 1.39. Calculating each side, on the left side, we get, and I'm using a calculator here, 9.73 if I round. If I don't round, 9.7284. I'm going to show it all out what the calculator gives me. And on the other side, I get 9.73. Now, notice I was tempted to round there. But let me show you that they aren't quite the same because we've rounded these values and we're checking with a rounded value. So the two sides aren't giving you exactly the same, but they're close enough, especially when you think about how you rounded the second decimal place, that they're basically the same values when you round again. So when you check with approximate values, you won't get exactly the same thing on both sides, but it'll be darn close. I'll leave the check of the other solution, negative 0.36, using that approximate value for you. But again, remember, often with quadratic formulas, we'll use two ways of showing the solutions, the approximate solutions and then the exact solutions.